from what I've heard this morning, other people have already forgotten. You may want to listen to this. A reminder that you have something to give me 1 week from today. The regression project, 1 week from today.
What is that?
Monday, April
I forgot
1st.
about that. Did I miss that day?
I don't know, it's on the calendar though. And
No, I mean like the assigning of the project.
well, I talked about it. Where can you find the regression package? On campus. Has anybody looked for it yet? Okay, did you find it? Print it out? Okay. So, I didn't mess that up and it's there. I still go with the thought that it'll take you somewhere between 1 and 2 hours. I strongly suggest that you do not wait until next Sunday to get started on it. Why? Because what happens is you get to Sunday at 7 p.m. and go, all right, I got to do this now. I don't feel like doing this. Matt, can I just look at yours? That's what people say. That's what happens. And as you know, as I have made very clear, that would be a really bad move on your part. So, don't do that. Hence, don't wait till Sunday to get rolling on it. If you do not have a graphing calculator, then you need to find ways to get in here to borrow mine. Mornings, afternoons. Mornings are better than afternoons. ACLab, etc. Okay? But I'll try to remind you each day, but I will probably forget. I shouldn't have to remind you every day now. You know, right?
Yeah,
Okay,
I know.
very good. Some people highlighted it on their own. You have to show now.
Yeah, it makes sense. I write notes there all day. I'm not going to be...
For me, that would be a problem because I could never erase them because I only shower once a month.
It makes sense.
I'm kidding. I'm kidding. Twice a month.
As long as it's twice a month, that's all we need.
Once a week, whether I need it or not. Kidding about that. All right. Thursday. Oh. I should probably tell you this. Wednesday will be my last day at Mountain Point. I am retiring after Wednesday. No, Wednesday will be my last day.
Wait,
Yeah.
the regression.
Well, whoever comes in to take over will take care of all of that. I'll make sure that I give them as much information as I can.
Why Wednesday?
Backing up?
I'm confused.
You weren't going to retire for a couple more years.
Well, but I'm not lying to you.
I'm highly confused.
I'm retiring after Wednesday. This Wednesday. Thursday, I expect that I will not be in, and I will be done. And it will be awesome. Well, $750 million will allow you to do that.
Wait,
Did you win the lottery?
I will Wednesday.
Oh,
okay.
I got it. We got the joke now.
Joke? I don't understand. Why do you think it's a joke? No?
This is time to wrap some
Think
What would you leave?
If you lose the lottery on
You just wait till last day of school.
Understand this. I love you guys, but
Just 2 more months.
Powerball is $750 million.
Well, you're actually looking at math.
I fully.
After all that ran through it,
But see, I have been playing it constantly, so the odds eventually get to the point where you're due, and at some point it has to happen. So
that's not true.
So I'm pretty convinced, I am convinced that it will be on Wednesday. So when you hear on Thursday morning that there was one winner of the Powerball and they were from Arizona, And then you walk in Thursday morning after your AIMS science test,
Which I won't be doing.
and I'm not here.
Wait, I'll be there for that day.
You'll know
I get to
why.
sleep in.
AIMS science Thursday is for, you're asking about AIMS science, right?
Biology.
That's what I'm talking about right now. AIMS science is for sophomores and also freshmen who are taking a life science. Does that sound correct?
Yeah.
If you took AIMS science last year, you do not need to take it again. It starts normal time on Thursday, 7:50. If you do not have to take it, first hour class begins at 10 o'clock. 9:59 to be official. So if you are not taking AIMS science on Thursday, you do not need to be in until, I'm going to say 9:59. You should get in earlier than that because invariably more people are late to first hour on days when they can come in late than any other time, like by far. So that doesn't affect us, but say 9:45. Do it that way. So room should be posted somewhere, I think. I don't have that. Yeah, probably in the science hallway or something like that. I don't have access to that, so you're just going to have to figure out. I will probably be in the room of some of you, hopefully. So that'll make my life easier, but that's about it. I don't know. I wrote it down somewhere. All right, anything else there? We good? Classes that day. We meet all of the classes on Thursday, and you will meet all of the classes for 38 minutes each. Except for your lunch class, like 4th or 5th, the one that's actually a class. That will be for an hour 20, no, I'm just kidding. It'll be for 33 minutes rather than 38 minutes.
Do we have
Which means
lunch?
that my 5th hour class will be the shortest one, my shortest one of the day.
Is that a good thing?
They're gonna watch the.
Lunch is late that day. If you have, how many of you have second lunch? I think it said second lunch that day starts, I believe, at 12:45.
That's like normal lunch time. It's
For-
not breakfast time
Yeah,
anymore.
but how many people have first lunch? Okay. On the weekends and that, aren't you ready to eat lunch at like 11 o'clock in the morning?
No.
Drives me nuts.
That's like.
Really? I'm so hungry by 11. Like 11:30 comes, and the girls are like, I don't want to eat lunch yet. I'm like, I'm starving. I have to get something. All right,
I don't eat it.
here we go. Ready? No, I need 2 more minutes, but this is math, chapter 7 related, and you need to listen. Okay? We have 2 chapters left of the year, chapter 7 and chapter 8. Chapter 7 is what we were about to start. In my opinion, okay, no, we need to listen now. In my opinion and from my experience, what I have found is that students find chapter 7 to be the most difficult chapter of the year. Okay? There are 2 different things typically that happen during chapter 7.
Everyone drops
2
out.
options as to what happens during chapter 7.
Everyone drops out.
Option number 1, you listen, you focus, you follow what's going on. You practice, 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 meaning you do all of your homework problems. You do not try to shortcut. You do things right. If you do that, then you'll be fine. You'll study for the test, you'll know what's going on, you'll come out of the test, and you go, oh, I wasn't nearly as bad as you were warning us it might be. That's option 1. Option number 2 is that you do what, maybe you normally do, which is you just sit around, you talk during class, you take your notes, but you don't do much with the homework. For the homework check, you get somebody's homework the day before, you do half the problems or something like that. If for some reason in this chapter, it seems to go to one extreme or the other. There doesn't tend to be something in the middle. If you follow option 2, Your scores on the test will typically be in the 20s or 30s%. Okay, this is all or nothing. We typically see scores in the 80s and 90s, and we see scores between 20 and 40. And that's what happens here. So you get to make that decision for sure, and you'll see what we're talking about today in class. All right? By the end of class, you'll probably be saying, well, that wasn't that bad. And then, depending on what you do tonight, will dictate how entrenched it is in there. With me? Nothing what we're going to do today is going to blow you away. Nothing. And then we'll say the same thing tomorrow. Wednesday might be a little bit more difficult. We'll see. Huh? No, well, let's see what we got. All right. Let's start with, there are basically 3 parts to today's thing. 2 of them are easy. 2 of them we've basically already done. The first one says something like, secant of theta equals 1 over cosine of theta, which is correct. These are called the reciprocal identities, which you know. You'll see something that says something along the lines of, if, and this is actually one of the homework problems, not one of the ones you have to do, because I picked an even one. But if secant of theta is equal to the square root of 11 over 2, find the cosine of theta. Go ahead. Ooh. Well, what is the cosine of theta?
2 over the square root of 11.
2 over the square root of 11, which we're not going to leave like that. We would rationalize it, and we would get 2 times the square root of 11 over 11. That's it. The first set of homework problems will look like that. Okay? I told you, simple. And a lot of this stuff is going to be simple. The next set says something along the lines of this. Tangent of theta equals, and there are a few different ways that you can do this, so fire out different things that tangent of theta equals, and I'll stop you when you get what I'm looking for.
Opposite over adjacent.
Opposite over adjacent is 1. What else? Tangent of theta is equal to
1 over cotangent.
Say it again. Okay. Sine of theta over cosine of theta. That's what I'm looking for. Be careful in this chapter. Okay? Be precise. I will do my best to not say that tangent is sine over cosine. I will do my best to say tangent of theta equals sine of theta over cosine of theta. When people make mistakes, it's because they try to shortcut talking through it and things like that. Especially once we get here, I'm going to try to model that behavior and to try to use the thetas and everything like that so that you don't make mistakes that you shouldn't make. You okay with that? You've seen that before, right?
Yeah.
Okay. If that's what tangent of theta is, then what is cotangent of theta? Cosine of theta over sine of theta. Yeah. Those are called the quotient identities. Those are called quotient identities. Again, nothing new, correct?
Yeah.
Okay. And you'll get some problems on those also. And then comes the highlight of the day. And those are what we call close. The Pythagorean identities. There are 3 of them. The first one says that sine squared of theta plus cosine squared of theta equals 1. For For those that are wondering, which is probably most of you, what does sine squared of theta mean? Sine squared of theta is exactly the same thing as sine of theta squared. Okay? It's just another way of writing it. That way you don't have to write parentheses and all kinds of stuff like that. So, and you will see that in every book ever. But yeah, when you see sine squared of theta or cosine squared of theta or something like that, it just means sine of theta quantity squared. Okay? So, there's our first Pythagorean identity. And to be honest, that one's actually pretty logical. Can I show you how? Okay. Thank you.
No.
No. Once upon a time, we used something like that. What did we call that? Unit circle. And we might have a point out here. And what would we call the coordinates of that point?
Oh, X and Y.
X and Y, right? But I also remember at some point us saying that X is equal to cosine of theta, and Y is equal to sine of theta. Which means that if we wanted to write the coordinates differently, we could write them as cosine of theta, comma, sine of theta. Fair? And so from this point, we could draw a triangle. So we go there, and we drop it straight down. We have our right angle, we have our theta. And so there's our triangle. What would be the length of this side of the triangle? Cosine of theta. Keep using the word theta. And the length of this side of the triangle would be sine of theta. What's the length of this side of the triangle? Why is it 1? Because it's a unit circle, right? And the radius from the center to a point on the circle is 1. So take that triangle and Pythagorean theorem that triangle. What do you get? Start with this side. Sine squared of theta plus cosine squared of theta equals 1 squared, which is just 1. And there's your Pythagorean identity, which we got by using the Pythagorean theorem, hence. So you see what I mean? Like, logically, you can see how this would work? Hopefully. All right. So, let's say, and this will be our main go-to Pythagorean identity. Okay? You will learn this, you will remember this one, you'll remember this one always. Okay? 5 years from now, you'll remember that sine squared of theta plus cosine squared of theta equals 1. You will. You may not think it, but you will. Even you. You're convinced. Anyway, moving on. But there are 2 others. Okay? So what I would like you to do is to take this entire identity and divide it by the cosine squared of theta. Well, I'm going to get to. So we're going to divide everything by cosine squared of theta. All day I've been wondering if you guys can see that.
No.
Not great. Not great. Yeah, but not great. That's it. All right, if we divide everything by the cosine squared of theta, what do we get?
Sine squared of theta.
Well, but I don't want sine squared of theta. Right? Sine squared of theta over cosine squared of theta will give us tangent squared of theta. Plus 1 cosine squared over cosine squared of theta equals secant squared of theta. And there is Pythagorean identity number 2. And then, if we divide everything by sine squared of theta, what do we get then? I'm sorry, where do we start? 1. Sine squared of theta over sine squared of theta is 1. Plus cotangent squared of theta equals what? Cosecant squared of theta. And those are our 3 Pythagorean identities. And we will use these a lot. And we will use them backwards and forwards and inside and out and left and right and everything like that. What do I mean by that? Well, one of the
Memorize.
things that I mean by that is, what is sine squared of theta equal to?
1 minus the cosine squared of theta.
It's equal to 1 minus cosine squared of theta. It comes from this first identity, and we just got sine squared by itself. Which means we could also say that cosine squared of theta
1
equals
1 minus sine
1 minus sine
squared of theta.
squared of theta. I would agree. And we will do that with these identities. In fact, we will probably use these 2 statements more than we'll use this one. And we'll definitely use it more than we'll use these 2. But that's what I mean by we're going to use them all over the place. What is, ready for this? What is secant squared of theta minus tangent squared of theta?
1.
Secant squared of theta minus tangent squared of theta is equal to 1. Now, if you actually think about that, that's kind of an interesting statement. Because what's theta?
We don't know.
Got no idea, right? And so what that's implying is that we can put in
Any value?
whatever we want for theta,
It's really cool.
and the secant squared of theta minus the tangent squared of theta will always be 1. Kind of interesting. We might be able to use that in other ways.
Shortcut.
And we'll see a lot of that later on in the week. Okay? You need to know these 3. You have to know the 3 Pythagorean identities. You need to memorize them. You need to know them. You need to be able to use them. Okay? I stink at memorizing. I always have. So rather than spending all of that time trying to memorize, you know me, I'm going to come up with some type of a system, shortcut, way to remember, things like that. So the first one to me, you're just going to have to remember. And you will. It's a pretty easy one. It's an easy one to remember. Sine squared of theta plus cosine squared of theta equals 1. If it, for some reason, doesn't click to you, just think of what we just did here with the triangle. Sine is y, cosine is x, boom. Sine squared of theta plus cosine squared of theta equals 1. Okay. For me, it's the second and third ones that become difficult. So how do I remember the second and third ones? Well, for me, I have a few little tricks for myself. Here are the things that I remember. Okay. First of all, the only functions that are in the bottom 2 are the tangent functions and the secant functions. No sine and cosine. The sine and cosine functions are just in number 1. Okay? So 2 and 3, my tough ones are tangents and secants only. In the identities, the co-functions are in the same one, cotangent and cosecant. And the non-co-functions are in one, tangent and secant. For me, that's a big one to remember. And then the other thing to remember is that the tangents are on the left side with the 1, and the secants are on the right side by themselves. Whatever works for you guys, go for it, but those are the ways that I remember them. So like, I've taught this for a long time, and I still don't off the top of my head have the secant and tangent one memorized. I gotta think it through, I gotta go through my rules. I'm like, okay, the tangents are on the left, so tangent squared of theta plus 1 equals secant, because tangent and secant go together and then the codes go together. So I actually have to think that out to this day. Sine squared plus cosine squared equals 1. I got it. But the other two are more difficult for me. Okay? Questions there? Erase this. Let's go here. If the sine of theta is negative 3/5, and the terminal side of theta lies in quadrant 3, find the cosine of theta. If I gave you no more instructions than that, what would you do to find cosine of theta? That's what I would do. I would draw a triangle. I always draw triangles when I have a chance. But
We're using that.
in this section, the directions specifically say, use a Pythagorean identity to find the function value indicated, rationalize the denominator if necessary. So we have to use the Pythagorean identities. Okay. Which one should we use for this problem? The first one, because we're talking about sine and cosine, and that one has sine and cosine in it. So, what are we trying to find?
3/5 squared.
So let's say that cosine squared of theta
Equals
equals,
1.
right? And if we're trying to find cosine, then let's get it by itself. Cosine squared of theta equals
1 minus 3/5 squared.
1 minus sine squared of theta. Does that make sense? I mean, we have it right up here also, but we just take it and we move it. And now let's start to plug stuff in. So cosine squared of theta equals 1 minus, I'm going to write it all out step by step, negative 3/5 squared. So cosine squared of theta equals 1 hang on. I'm hearing minus and plus, so I want to get,
It's still because you're squaring the parentheses.
so I should write
Minus.
minus, okay.
9/25.
9 over 25. You can already start to see the silly little mistakes that people are going to make, right? I mean, some people, and understandably so, saw minus, minus, and instinctively said, okay, this is going to be plus. Take your time. You'll notice that I put it in parentheses. Take your time, be precise, attend to precision, do all of those things that we talk about. 1 minus 9 over 25. Do you remember the shortcut to do this?
No.
If it's 1 minus a fraction, just subtract denominator minus numerator. Cosine squared of theta equals what? 16 over 25. And so therefore the cosine of theta equals
4/5.
4/5. Sound good? See, I say something like sound good, and at this time of year, people go, right? Back in August and September, the reaction would have been, yeah, I got this. But now you're going,
What's next?
What's next?
did we miss something?
Did we?
Did we miss something?
No.
Yes, we did.
What?
So what?
Quadrant 3.
Quadrant 3. Uh-oh! Quadrant 3, what does that mean? It means it's negative. Wait. I'm confused by that.
Wait, sine
Can
of
Math
we-
teacher.
Can we just take a number and make it negative whenever we want? Here, 3 plus 2, what's 3 plus 2? 5. But I really want it to be -5, so I'm going to say it's -5. Sound okay?
No.
No, that doesn't make any sense, right? So that would mean that either that's not the answer, or we did something wrong. Which are you guessing at this moment? I'm
The
guessing
right
that too.
Magic.
Let's see, let's go through what we did. Cosine squared is 1 minus sine squared of theta, so we're good there. We plug in the sine squared of theta as -3/5, that's good. We squared -3/5 and got 9 over 25, 1 minus 9 over, okay, we're good there. What was our next step here?
Oh, plus, is it plus?
What was our next step here?
Square root.
We square rooted what?
Plus or minus.
We square rooted what? We square rooted what?
Fraction.
Both sides. We square rooted both sides. Anytime, I remember this now. Anytime we take
The
the square root
Of
of both sides of an equation, we must take plus or minus square root of the number. I remember giving that to you in August and saying, write this, big letters, capitals, circle it, start, because we're going to talk about this a lot. And guess what? We're talking about it now. We've talked about it a number of times during the year, too. So, our answer is cosine of theta equals plus or minus 4/5. No. Why not? In quadrant 3.
So it's negative.
This tells us what cosine of theta can be. If we solve this equation as we have it right here, it doesn't know what quadrant we're in. It doesn't know what we're doing. It's an equation. But it does say that the cosine of theta could either be positive 4/5 or negative 4/5, comma, you decide. And so what are we deciding? Cosine of theta is negative 4/5 because theta is in quadrant 3. You got it. Does that make sense? You think we're done now?
I found it.
Now we're done.
This many notes
Now we're
later.
good. Here is the next one. Oh.
I'm gonna make boxes around problems just so I can look at them for reference.
If the cosine of theta